Welcome to this short guide on sifting sediment to collect Lophopus crystallinus statoblasts. Here's what you'll need: a bucket and a small tub or two similar vessels for collecting and sorting your sample, as well as various size sieves including a 1 cm, 850 micrometre and a 425 micrometre. You'll also need access to clean water, a couple of trays, a hand lens or a magnifying glass and a microscope. Start by collecting sediment from the blowwell. Look for areas near rotting substrates and gentle currents where statoblasts might accumulate, using the Veen Grab to collect the sediment and then scoop it into your bucket. Please refer to the sediment grab video for the setup of the Veen Grab. Once you have done this, return from the field to a suitable workplace. You will need running water and a sink where you can prepare your sample. Next, take your 850 micrometre sieve and place it into the tray, and then place the 1 cm sieve on top. This helps separate the finer particles and organic matter, leaving behind larger materials. Pour a small amount of sediment each time into the sieve until you have a good size amount. You will then need to gently rinse the 850 micrometre sieve through the clean water. Be careful not to rinse too much water and risk overspilling, losing your sample. You can also gently tease the finer particles through your sieve with your fingers. Then, taking your 1 cm sieve, place it into the top of your bucket and gently rinse thoroughly, washing the larger debris and hopefully clearing any stuck statoblasts into the bucket. Then clean down your bucket and pour the remaining water through the 850 micrometre sieve. Once you've completed this, you can then discard of the leftover materials into an appropriate waste area, such as the bin, or alternatively take it back to the field once you are fully finished. You will then need to take the 425 micrometre sieve and place it into your second tray. Then, removing the 850 micrometre sieve, sit it on top of the 425 so you can begin further filtering of the sediment. Next, you will need to pour the remaining sample out of the tray into your bucket and rinse the tray thoroughly to remove any remaining deposits. Returning to the sieves, begin washing thoroughly to dry through the remaining finer sediments, from the 850 micrometre sieve down to the 425 micrometre sieve. Once you are satisfied or the 425 sieve has become full of water, please remove the 850 sieve, then pick up the 425 sieve and repeat the process. At this point you should start to see a nice fine particulate being left within the sieve. Now, taking a clean tray, begin by filling it with water, ready for statoblast searching, taking your tray through to the classroom so you have a clean work setup. Next, remove the 425 sieve from the tray and empty the contents back into the bucket, remembering to give it a wash out so you can repeat the process later. You can also then use the tray to carry your sieve and sample through to the clean workspace. Removing the sieve, place it into the empty tray filled with water upside down. Then, taking the prepared tub of water, pour it directly over the sieve to release all of the fine-grained sediments, ensuring as much coverage as possible. Next, we will need our hand lens, magnifying glass, some microscope slides or a petri dish. You can also use a torch to help brighten up the tray, which can really help to get your eye in. Start by methodically making your way across the tray, remembering the statoblasts are roughly 1 mm in length and 0.5 mm width, so they are very small and you will need to take your time examining each area in great detail. If the statoblasts have dried out, you may find them floating on the top of the surface of the water. Using the flashlight can help shine light through the statoblasts, highlighting their chitinous shells and the egg sac within. Once you've identified a potential statoblast, you can use a pipette to gently extract it from the water. Be very careful, as due to their minuscule nature, any movement can easily shift them within the water, so go slowly and steadily as much as possible. After successfully pipetting them, you can either use a hand lens or a microscope for a positive identification. Lophopus crystallinus statoblasts are uniquely shaped compared with any other freshwater bryozoan, which is great for identification. Thank you for watching.